What's anything to the 1? Itself. So therefore, a plus b to the 1 would just be a plus b, right? Okay, how about a plus b squared? Ooh, that was close. A squared plus 2ab plus b squared. Some of you had that memorized, and some of you are like, FOIL it and you'll get there, right? Okay, how do we do a plus b cubed? Pause. How would you have to solve it if I asked you to actually solve for it? Write it. How would you solve it if I asked you to solve for it? 3 times. 1, 2, 3. FOIL the first 2. This guy, take this guy and multiply him by another a plus b using polynomial multiplication. Distribute, 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 and then combine. Why is Colby saying Pascal's triangle? Because Pascal's triangle is a shortcut, and it's a very nice shortcut, which allows us to, Colby, can you get there? A cubed? And a similar idea will help us with a plus b to the 4th, because we could write a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. Whoo! Does that, whatever I just used and whatever Colby just used, did that sound better than you actually multiplying it 2 or 3 or 4 times? Oh. So then what were we using? What we're missing is technically a plus b to the 0. And a plus b to the 0 is 1. Look at the coefficients of what you have left. To the 0 power, 1. To the first power, a 1 and a 1, 1a plus 1b. To the second power, a 1 and a 2 and a 1, a 1a squared plus a 2ab plus a 1b squared. For a third power, 1 and 3 and 3 and 1. For a fourth power, 1 and 4 and 6 and 4 and 1. Where are these numbers coming from? After you have the first 3, 1 plus 1 is 2. 1 just stays, 1 just stays. 1 plus 2 is 3, 2 plus 1 is 3. The 1s just stay. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. The 1s just stay. Whoa! This is called Pascal's triangle. I'll just put triangle. Pascal's triangle, where the coefficients of raising binomials to higher and higher powers definitely follow a pretty cool pattern. However, that just gives us the numbers in front, and that's only when we have 1a plus 1b. If we have, for instance, 2a plus b, it would be a little bit different. Or maybe 3a minus 2b, it'd be a little bit different, but the pattern still remains the same. These numbers do go in front, but question, Colby, how did you figure out what to put next to the numbers when you read off the third power one? You go down a power of the first term. So it starts at the very highest, a cubed, and it counts down a squared, a to the 1, then it's gone, a to the 0. And as a counts down, what does the second term do? Counts up, b to the 0, b to the 1, b to the 2, b to the 3. Down here, the binomial theorem says to expand any binomial, x plus y to the n, we always start with the first term raised to the highest power. Then we count down by 1s of that power until eventually that x just goes away because it'll be x to the 0 at the very last term. The second term is going to go ahead and count up until it reaches its highest potential. And what's in front? Ooh, wait a minute. There's a math way to express what's going on in Pascal's triangle? To figure out the special number that needs to go in front from Pascal's triangle, we can actually do the snazzy NCR. Where? N, wait, where do you guys see N? Who's he? The exponent, good. So N is going to be the exponent that the binomial is raised to, the power it's raised to. And what's R? Ooh, this one's a little bit harder. N is the exponent, and R, where do you see R? N minus R, y to the R. R is going to be the power of the second term in the expansion. So whatever you're trying to find, r is going to be the power of the second term in the, look, isn't it y? So whatever term you're in, it's going to be the power of y. So for instance, what would r be in this term right here? 2. What would r be in this term right here? 4. It's the power of the second term. What's r in this one? 0. So r counts up, starting at 0, r counts up based on what term you're in, ending at its highest potential, ending at the exponent. But what else do you guys notice? To keep yourselves honest, what happens to the sums of the powers? Just adding them together, just a little trick. It's nothing mathematical in combining, but what happens to the sums of the powers wherever you are? It stays adding to be the highest power that, or the power that you're raising the entire binomial to. So this is one way of writing it. This formula is one way of solving it, factorials. And this n over r in parentheses, no division line, it's not a fraction. Just n over r is another way of writing it. So for instance, we could go ahead and write in, this is horrible, oh, it got bumped, that's why. There we go. Pascal's triangle that I wrote up above can actually be written another way. Oh, that is Pascal's triangle. Pascal's triangle can actually be written another way. But before we get there, I'm just trying to go too fast. Don't worry, we're not doing the entire section. You guys have a formula, so how would we solve 8c2? 8 is n, 2 is r. Using the factorial is probably the easiest way. Or else we'd have to do the binomial, we'd have to do the Pascal's triangle all the way down to the 8th row. Which some of you might be like, yay, let's go. But for others, you're like, nah. So kiddos, I want you to go ahead and plug into the formula. Ready, set, go. What is the formula? N factorial. Okay, good. So you know n is 8. You know r is 2. Go ahead and plug in, Jug. Let's see if I can beat you. I doubt it. What row did we have to get to? 8th row. What term did we have to get to? R is equal to 2, but R starts at 0, so your final answer should have been 28. If I did my Pascal's triangle right. Did I? You guys plugged into the into the formula, right? 8 factorial all over, what is it? N factorial all over n minus 2 factorial times 2 factorial? Cool. Can't you simplify that to be 8 factorial all over 6 factorial times 2 factorial? Can't I change 8 factorial to be 8 times 7 times 6 factorial? All over 6 factorial times 2 factorial? Isn't it 8 times 7 times 6, 5, 4, 3, 2, 1, 6, 5, 4, 3, 2, 1? Can't I cancel those out? And can't I say 8 times 7 is 56, and 56 divided by 2 times 1, 2, is equal to 28? Dun, 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 dun. Oh no! How would you do this guy? Same thing, except now I'm doing 10 and... Now you guys saw me do mental math. Do mental math. Your turn. Some of you were kind of stuck on the last one. Colby's just doing the big math facts. I like to break it down into little pieces. He's doing the big pieces. I could keep going. What's R equal to? Did I find it? But could you guys have found it also? Can't I say, let's see, 3 goes into 9 3 times, and 2 goes into 8 4 times, and so 3 and 4 is 12, and 12 and 10 is 120? Dun, 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 dun. Colby. Wait, what about 7 0? That's 7 factorial all over 7 factorial 0 factorial. Isn't that DNE? 0 factorial is defined to be 1, so this is just going to be, why does that make sense? Oh, isn't 0 the first term? Isn't the first term always going to be 1? Oh, okay, how about this guy? It's the same thing. Why does that make sense? That's 1, that's 1. Oh, wait, isn't this going to be at the very, very end? What's the last term every time? So how does this all work? Even though I already showed you the pattern of that on the board, you could go ahead and say that this could be similar to Pascal's triangle is completely comprised of these special coefficients denoted by n and r. We call technically, in probability, we call them combinations. Now, why do you think it's helpful, if we could just do Pascal's triangle, why do you think it's helpful to have some sort of, hey, NCR, which is the same thing as N over R, has an actual formula that I can solve? Why does that sound like a good idea? Why didn't they just stop with Pascal's triangle and say it's a pattern? Last thing for today. What if I was to ask you? Let me do a full screen. Pascal's triangle is super cool. Some of you might actually want to use it, maybe not even just for like the second, third, fourth powers, maybe for like up to the 10th powers. But what if I was to ask you for something like find the x to the 5th term in the it's going to be too confusing if I do it that way. The 2x minus 3 to the 10th power expansion. Ah, ha, 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 ha. What if that was the question, which is actually like some of your homework problems in this section? What would you do? All right, I have to do Pascal's triangle all the way down to the 10th power, which is going to be the 10th row. Well, technically the 11th row, where I have a 10. Huh? Well, here's the problem. It doesn't just want the special coefficient from Pascal's triangle. According to binomial theorem, I don't even want necessarily the x to the 5th term. Wouldn't that be x to the 10th is first, then 9th, then 8th, then 7th, then 6th, then 5th? Okay, yeah, we could have kept going, right? If we had kept going, that would have been 200. Is it 210 that's next?
Yeah.
Is that right? And then I'd have 252, and then 210, and then 120, and then 45, and then 10, and then 1. Okay, so I would need for the x to the 5th, that's x to the 10th, 9th, 8th, 7th, 6th, 5th. Here's my x to the 5th term. But guess what? 252 is wrong. It's part of it, but it's wrong. And here's why. Binomial theorem. Didn't you write it down today? To get to the x to the 5th term, that's going to happen when r is equal to, technically if I was to count it, 0, 1, 2, 3, 4, 5. When r is equal to 5. I could just say that's going to be 10c 5 x to the 10 minus 5, but here's the struggle. It's not x that's being raised to the power. What's in the first spot? What's in the a spot? 2x is being raised to the n minus r power. And what's the second value that's being raised to a power also? -3, because it's plus and negative. That would be b. So there's my a, there's my b. And b is being raised to, well, hold on, wait. If x is being raised to the 5th power, if this term is being raised to the 5th power, what power must this be being raised to? The 5th also. Binomial theorem says, okay, it'd be way too hard to multiply this whole thing out to the 10th power and find this guy. And even Pascal's triangle, that 252 is really, really good. But is he all that's there? And the answer is nope. Aren't there some other numbers that are also going to contribute? So someone with a calculator to finish off our final example of the day, 252 times 2 to the 5th times -3 to the 5th. What is the coefficient of the x to the 5th term in this expansion? Melody's working. Janelle's working. Thomas is working. 252 times 2 to the 5th times -3 to the 5th. Jack's coming on board. Dean's working. $1959 what? 552. Was that 252? And the answer was no, but was 252 a part of it? And the answer is yes. You guys think we have enough? Enough of 95? Yeah, me too. All right, here's the dealio. Let me pause the recording.